few more concepts. They are important and some typical concepts in the probability distribution function. Just we are again coming back to the probability distribution function. There we see chi-square distribution. First we understand what is the chi-square distribution and what is the use of chi-square distribution. That is chi-square distribution. Here we write it by like this. It is chi-square. Greek letter chi from the family of alpha beta. It's chi-square distribution. When the sample size is very large, the probability distribution of the chi-square we can closely approximate it by a continuous curve. That is called the chi-square curve. In this manner, that is this. Or for the different values of the degree of freedom, here we see degree of freedom is equal to 15, and here degree of freedom of the variable, that is equal to 5, and here in this side we take the value of chi-square. The chi-square, with the help of chi-square, we can find the relation between the observed values and the expected values. Observed values, which is the data collected by the survey, and expected value are those which are calculated on the basis of the previous records available with us. Now, here in this section, we have not to study about the solution of the chi-square distribution, but we have to connect this with the moment generating function in the chi-square distribution. What is the moment generating function? That is f of x. It is in the signum form. F of x is equal to, we write in this way, that is 1 upon 2 raised to the power n by 2 into, it is called gamma function n by 2 into e raised to the power minus x by 2 into x raised to the power n by 2 minus 1. It is when x is greater than 0, and otherwise in any other case the value of this chi-square function is 0. It is the chi-square function 1 upon 2 raised to the power n by 2 gamma function. This is called the gamma function n by 2 into e raised to the power minus x by 2 x raised to the power n by 2 minus 1. Now we see what is the gamma function. Say the gamma function for any value a. We can represent it. It is the integration from the 0 to infinity of x raised to the power a minus 1 into e raised to the power minus x into dx. This is the definition, or you can say the formula for the gamma function. Here we are discussing not about the chi-square distribution. With the help of the chi-square distribution, we can also find out the fitness of the given data, rather the given data is applicable for the further use or not. Now here our purpose is to discuss about the moment generating function for the chi-square distribution. For that we use this formula for f of x, where gamma function for any variable say x is denoted by x raised to the power a minus 1 into e raised to the power minus x into dx. Let us consider an example, very important example, or you can say theorem. Both are equally good for this concept. That is, show that moment generating function of a random variable x, which is chi-square distributed with it is v, letter v, degree of freedom, which we check it from the tables provided with the chi-square distribution, is moment generating function t is equal to 1 minus 2t raised to the power minus v by 2. You can consider as a theorem or a result or a numerical. Simply, all these are the theoretical calculations. No, your function is, first of all, in spite of f of x, it is a moment generating function t. So first, in the solution, we write our function mt, that is equal to m into e raised to the power tx, that is equal to 1 upon 2 raised to the power v by 2 into gamma function of v by, it is v by 2 into integration from 0 to infinity e raised to the power tx, that is this function, value of t. Here we have taken the value of t is e raised to the power tx, and in the standard formula where we used n was also the degree of freedom, but here in this particular case we are given the degree of freedom v, so we use v instead of n also denotes the degree of freedom, but according to the given problem we will have to use v in place of n. E raised to the power tx into x raised to the power v by 2 minus 1 into e raised to the power minus x by 2 with respect to x. Now it is a moment generating function. So we will have to calculate it. For the given result we have to prove mt is equal to this, that is equal to, say, 1 upon 2 raised to the power v by 2 gamma function v by 2 from 0 to infinity, it is e raised to the power tx minus x by 2. If both bases are same, then powers are added, into x raised to the power v by 2 minus 1 into dx, that's equal to 1 upon 2 raised to the power v by 2 gamma function for v by 2 integration from 0 to infinity, and we take x common from here, that will give t minus 1 by 2 into x raised to the power v minus 2 divided by 2 after taking the LCM. First we will simplify the function for our further calculations. That is equal to 1 upon 2 raised to the power v by 2 gamma function of v by 2. Here v denotes, again I say, the degree of freedom. Integration from 0 to infinity e raised to the power x into 2t minus 1 divided by 2 into x raised to the power v minus 2 divided by 2 with respect to x. That is equal to 1 upon 2 raised to the power v by 2 gamma function of v by 2 integration from 0 to infinity. Here we write x v minus 2 divided by 2 into e raised to the power 2t minus 1 into x by 2 with respect to x. But what if we see the over result requires the factor 1 minus 2t, but here we are getting 2t minus 1. So better take the minus as common at this step. That will be the helpful for the further calculations. It is the gamma function of v by 2 integration from 0 to infinity x raised to the power v minus 2 divided by 2 into e raised to the power 1 minus 2t into minus x by 2 into dx. We have taken a minus common from this set. That is equal to 1 by 2 raised to the power v by 2 gamma function of v by 2 from 0 to infinity e raised to the power e raised to the power 1 minus 2t into minus x by 2 into x raised to the power v minus 2 divided by 2 with respect to x. Nothing we have done, only we have interchanged the values left to right. No. Put here we put 1 minus 2t into x raised to the power 2 is equal to u. That is the power of x. 1 minus 2t into x by 2 is equal to u. Here we get x is equal to 2u upon 1 minus 2t. Then differentiate both sides with respect to u. Differentiate both sides with respect to u. U is our new variable. So we get here dx is equal to 1 minus 2t 1 minus that is 2 upon 1 minus 2t into du. It is a constant. This factor 2 upon 1 minus 2t, it behaves as a constant because the original variable was x and we have substituted x is equal to u. That is the differentiation for this. If we again check, that is m moment generating function e raised to the power tx, that is equal to 1 upon 2 raised to the power v by 2 gamma function of v by 2 integration from 0 to infinity. We put these values in this step. Say it is number 1. Here first of all we see for x. Here x is 2u upon 1 minus 2t raised to the power v minus 2 divided by 2 into e raised to the power minus u. Here all the function we have put is equal to 2, only negative is left. So what's about dx? Dx is 2 upon 1 minus 2t into du. That we have changed the variable. There will be no effect on the limits. It is from 0 to infinity. If we change the limits, they will again come from 0 to infinity. That is equal to 1 upon 2 raised to the power v by 2 gamma function of v by 2 integration from 0 to infinity. Here we separate the 2 raised to the power v minus 2 divided by 2 into u raised to the power v minus 2 divided by 2 into e raised to the power minus u into 2 upon 1 minus 2t into du. That is equal to 1 upon 2 raised to the power v by 2 gamma function of v by 2 from 0 to infinity 2 raised to the power v minus 2 divided by 2 plus 1. That we have added the both two. Bases are same, powers are added. Plus 1 into u raised to the power into e raised to the power minus u into u raised to the power v by 2 minus 1. Separate the terms into 1 upon 1 minus 2t here it was the term 1 minus 2t raised to the power v minus 2 divided by 2, and here it was 1 minus 2t raised to the power v minus 2 divided by 2 into 1 upon 1 minus dt into du. Now we compile all the similar factors and the variables. Let us say that is equal to, it is outside same, 1 upon 2 raised to the power v by 2 into gamma function of v by 2 integration from 0 to infinity. It is 2 raised to the power, we see v, if we calculate this one, 2 raised to the power v by 2 into e raised to the power minus u into u raised to the power v by 2 minus 1. No, both these factors, they will become 1 upon 1 minus 2t into v minus 2 divided by 2 plus 1 into du. That is equal to 1 upon 2 raised to the power v by 2 gamma function v by 2 from 0 to infinity. We take it outside into 2 raised to the power v by 2 e raised to the power minus u into u raised to the power v by 2 minus 1 into 1 upon 1 minus 2t raised to the power, it is v by 2 with respect to u. Here it cancels, that we give 1 upon gamma function of v by 2 into u raised to the power v by 2 minus 1 into e raised to the power minus u into 1 minus 2t raised to the power minus v by 2 into du. That is equal to 1 minus 2t raised to the power minus v by 2 divided by gamma function of v by 2 integration 0 to infinity u raised to the power v by 2 minus 1 into e raised to the power minus u into d. If we compare with the result in the starting which we denoted that it represents the gamma function. It represents the gamma function for v by 2. That is equal to, if we take a is equal to v by 2, that is equal to 1 minus 2t raised to the power minus v by 2 divided by gamma function of v by 2 into gamma function of v by 2, and it cancels, and that gives the result that is equal to 1 minus 2t raised to the power minus v by 2. That's all regarding the movement generating function associated with the chi-square distribution. However, its formation is typical, but it's very important in the probability distribution when we discuss in the different types of the distributions. That's all for this topic, and I think we have discussed, I'm sure or not think, that we have discussed almost all the topics associated with our IGNOU booklets. Rather, some were simple, some were somehow typical, but their nature is as it is, and we will have to go through them. You can also put your question on the discussion form available on the site, and I will check from there and reply to your problems. Anyhow, thank you.